Hi, everybody. I'd like to go through a script that um, tries to model the wildlife to human settlement frontier and potential transmission of viruses in particular or other microorganisms from the wildlife area to human area. That's a major source of risk for human life is the possibility, as we saw with COVID-19, the possibility of a virus that is uh, on the wild side of nature, the animal side, the plant side, the microorganism side, somehow evolving or being transmitted over to humans. And then, since humans would have no natural evolved immunity to it because by definition, this is something that has evolved without much human interaction or contact. Humans might be very susceptible to such a microorganism or virus and may not be able to develop a cure in time to prevent widespread deaths or even extinction. So that's our purpose of this little script. So we're going to explicitly map the geography of these wild human settlement interfaces or frontiers. So we're going to use the package SF, which stands for Simple Features, Tidyverse, and tmap, which is a R package for mapping things. So I've loaded them. I'll clear the environment. And then the first thing that I'm going to do is define some area of the world that I know where that this interface is important. Obviously, it's perhaps not very important in Chicago or in Paris. So we'll take the Brazilian Amazon. There are many such natural areas with very limited human habitation around the world, and this is arbitrary. Obviously, the Amazon is a big one. Congo Basin's another big one. Parts of Southeast Asia are others. Mountainous areas might be others. Antarctica, maybe not that many microorganisms there. Siberia. So we can think of many different locations where there's been very little human interaction with the natural world and might be a source of jumping over of viruses or microorganisms. So just looked up a map and have some basic idea of where the Brazilian Amazon is located and find its center latitude and center longitude, and then define a box to be uh, 1.5 longitude on either side and 4 degrees latitude on top and on bottom. So that'll define a rectangle. So we'll just put these into our as values in our environment. Then we're going to use the ST B box, bounding box. We're going to use these coordinates that we just gave it. We're going to give it a coordinate reference system. You should Google what a coordinate reference system is. And we'll call that AZ for Amazon bounding box. And then we'll turn that into a polygon that our tmap program, tmap package will be able to display as a map. So we create the box, the rectangle really, and then the um, set of polygons. And now we can use tmap. Tmap function typically at its base has just 2 parts. First, which shape data frame is it that you wish to display? And then what's the geometry of that display? What is it that you want to display? So we want to display the data frame, which is a simple features data frame. It's called frontier polygon, and we just want to have the borders of the polygon. So when we draw this, we're going to get a rectangle. Um, and there's our rectangle. Because I have my default set to tmap view mode, it gives me behind the scenes the OpenStreetMap map of the world, which I can click on here and see, okay, this is indeed the Amazon. If I moved uh, 4 degrees to the east and we rerun the whole thing, we're going to see the bounding box shift 4 degrees latitude over to the east. And you see there, it is now shifted over. Now it's incorporating many more settled spots. So that's our bounding box. I'm going to redo this, but not draw it again. Then we're going to generate 200 random points. So 200 points. We're going to look at the latitudes and longitudes. X is the longitude in this case, Y is the latitude in this case. And we're going to just draw points from the uniform distribution. So any point is equally likely between the uh, in the case of longitude, the easternmost point and the westernmost point, in the case of latitude, between the southernmost point and the northernmost point. So we're going to just draw these points and then combine them to be, here we'll combine them to be 200 observations. We look at this and we see, okay, latitudes here, longitudes are here. So now we have 200 points. We're going to turn this into a simple features data frame with this command st as sf, where we're turning coordinate points into simple features. So now we see that our points data frame has a geometry and it's a whole 100 points. Our geometry is just points. And then we can draw this. Remember, two-part to using tmap, which simple features data frame is it that you want to display and how do you want to display it? In this case, we want to display these as dots. So we're just going to get a map of the 200 dots here. And default is black here. Now we can put the two together so we can have the frontier, the rectangle, and we'll just do it as a border. Um, and then we'll have the points inside that border. So when we rerun this, we now have the frame, the border, and the dots inside the border. Now, notice, there's some weird stuff could be happening. There could be a dot that happens to be exactly on the border. There's always weird edge cases that, for our purposes, we have no need to be concerned with. But you should always be aware that, oh yeah, weird things can happen here. If you happen to have a dot right on the border, how's R going to treat that? How are the packages going to treat that? Now what we're going to do is use a nice simple features command called stbuffer, and we're going to draw what we'll call little settlement polygons around each one of these dots. So we'll imagine each dot is some camp where miners or cattle herders or rubber plantation, they've set up some camp. They have 500 people or 1,000 people. Maybe they're using little bush planes to fly in and fly out, or canoe, maybe they're using boats and they're going on the rivers. So we'll call these the settlement polygons, and we'll have our buffer. We'll draw these polygons in all these 200 polygons then in red, and you'll see that we now have these in red. If we looks like they're points, right? Because polygons are pretty small, but as we zoom in, we can see that the polygons are actually around these around each one of these points. And it's just drawn them as circles. When they're pixelated, they don't always show up as circles. They look more like hexagons. But if you zoom in, you see that they are somewhat pixelated circles by that's how many, that just limitations of our computer, that we can't draw perfectly fine continuous lines. They have to be pixels. So that's our buffer zones. And now we can take the union of all these polygons and calculate the length of all the polygons, divide by 1,000, the length of the perimeters of all these polygons, and that'll tell us what the perimeter is of the human boundary. So it's 12,000, almost 13,000 kilometers. If we made the buffer width smaller, so we could redo this, and I won't draw the map again. So now the buffer zone around each point is smaller. So of course our perimeter is going to be smaller. So our total perimeter is going to depend on how many points there are, how big they are, whether they, to what degree they overlap. So now we only have 7,000 kilometers. And then I think we already did this map and already did that map, right? So we have points. You can change the latitude and longitude to map any place in the world and change these the size of these points, the number of points, and then you'd have different values for this perimeter of wildlife. So that's how this part of the script works.